Hello, I am Ashton Sparrow, and this is for my second final product for chemistry. As you can see here, the anode side is the zinc, and the cathode side is going to be the copper. We have a wire attached to both of them, and in the middle we have the load, which will be our multimeter, and it will read positive in this case. Okay, now let's get into the first step, which is going to be oxidation. Oxidation means losing electrons, and electrons are leaving the solid anode zinc atom, and it is dissolving into the, I cannot pronounce it, but aqueous solution. And you can see that with the zinc to the second, and that will be in liquid form, while the two electrons are going to be going to the load. Here is the electrons entering in the load, and this will read a positive voltage. The electrons continue to go through, and now they will be going to the cathode side. Our next step here is reduction, where electrons are added back in. The electrons from the wire paired up with dissolved cations at the cathode, and that makes the solid copper. So now I am modeling the salt bridge, and basically the salt bridge function is to balance the positive and negatives of the anode and cathode. And here's it kind of mixed up, and there's the same amount, but it will be balancing up in this next picture. Now you can see that it balances out again. This has been my model for the Daniell cell, and I do want to go over some limitations of it. Some limitation is that it's definitely non-accurate number of the amount of atoms, and the size is just completely out of proportion. Atoms are not that big, so it is misdrawn in that way. Now the purple on the salt bridge, those little dots are actually representing the potassium, which is a positive charge, and that evens out the chlorine's negative. I chose to model it like this so you can see what the model is actually doing up close.